Good morning, students. Today we'll discuss about the Keter's pendulum. Keter's pendulum is a type of compound pendulum and it is used to determine the acceleration due to gravity. It consists of a metal bar. This, as shown in the figure, this is the metal bar. Its length is nearly about 1.5 meter, and the weight of this iron rod is approximately 25 millimeter. The this type of pendulum is shown in the figure. In the pendulum, this is the metal cylinder, metal weight, and it is of a type of a cylinder type. This metal cylinder type of weight is inserted into this iron rod, and for the adjustment of the center of mass of the pendulum. Then again, two more weights are there. One is of metal and other is of wood. These two weights are adjusted by a micrometer, and it is for the adjustment of the time period. When this is the NIF K1 and this is NIF K2. When this pendulum is suspended at NIF K1 and the time period is measured, and suppose that time period may be anything, and this pendulum is inverted and suspended at NIF K2, then the time period is measured, and that time period should be nearly equal to the time period when the pendulum is suspended at K. If there is a difference between the time periods, then that time what this metal cylinder, small metal cylinder weight and this wooden weight is adjusted so that the time period from in both the cases nearly equals to the same. Now, when pendulum is and this L1 is the length of the pendulum from the leaf edge K1 to center of mass, and this L2 is the length of the pendulum from center of mass to leaf edge 2. Now the total length of the pendulum is denoted by L. Therefore, L equals to L plus L1. This L length of L does not change. Now, if this pendulum is allowed to oscillate freely and its time period is calculated, the time period is equals to T1 equals to 2 pi under root of K square plus L1 upon L1 raised divided by Z. This is suppose when this Keter pendulum is suspended at K1 and its time period is calculated. Suppose calculated, and it is equals to T1 equals to 2 pi under root of K square by L plus L1 upon Z. This is the time period for the pendulum when it is suspended at K1. Now, if suppose this pendulum is inverted and its time period is calculated, if pendulum is inverted and it is suspended at K2, and its time period is calculated, and that time period is equals to, suppose it is equals to T2. T2 equals to 2 pi under root of K square upon L2 plus L2 upon Z. Suppose this is equation number 1 and this is equation number 2. Now what we want to do, we want to calculate this Keter's pendulum is used to measure the acceleration due to gravity, but that is the value of G. Now we have calculated first the time period T1 and the time period T2. Now the squaring this equation squaring equation 1 and 2. Squaring equation 1 and 2. If we square this equation 1, then this equation becomes t1 square equals to this 2 pi, it becomes 4 pi square. This under root sign, the things inside the under root, that will be like this: k square plus L1 square upon L1 into z, and this is the simplified form of the equation number 1. Now this equation can be written as like this: t1 square into L1 is 4 pi square upon z into k square plus L1 square. This is equation number 3. Similarly, we will square equation number 2, and squaring the equation number 2, what we get? t2 square equals to 4 pi square. t2 square equals to 4 pi square into k square upon plus L2 square upon L2 into z. And this equation also can be written as t2 square into L2 equals to 4 pi square upon z into the bracket k square plus L2 square. This is equation number 4. Here we have simplified this equations 1 and equation 2 by squaring it. Now we have to subtract equation number 4 from equation 3. Now what I do, I simply omit this part, equation 1 and equation 2. Now this is equation number 4 and this is equation number 3. Now what we said, we are now subtracting equation 4 from equation 3. This can be done in this way, that is equation 3 is t1 square L1 minus t2 square L2 equal to, this is the part of the equation 3 and this is part of equation 4, that is the left hand side of equation 3 and 4, subtracted from the left hand side, subtracted from the left hand side, and right hand side subtracted from the right hand side. The right hand side is like this: 4 pi square upon z into the bracket k square plus L1 square minus 4 pi square upon g into the bracket k square plus L2 square. Here t1 square plus into L1 minus t2 square L2 equals to 4 pi square upon g is the common, and into the bracket k square plus L1 square minus k square minus L2 square. This case plus k square minus k square will get cancelled, and t1 square into L1 minus t2 square into L2 equal to 4 pi square upon g into the bracket L1 square minus L2 square. L1 square minus L2 square. This is the simplified form of the equation, and we will number this equation as equation number 5. This is the equation number 5. This is equation number 5. Here, what we do, so by careful adjustment of the positions of the weight, this metal weight and this wooden weight. By careful adjustment of this weight, two weights, the time periods, the positions of these two weights, the uh, time period about K1 and K2 becomes or nearly equals the same. Therefore, we can assume that by we can write here by so by careful adjustment, of weight or position of weight, time period about knee phase K1 and K2 are nearly equals to the same, are such that about K1 K2 is such that the time period nearly equals the same. Nearly equals means by the adjustment of these two weights we can whether the pendulum is suspended at K1 or K2. The time period by the adjustment of these two weights, the time period makes the nearly equals to the same. Therefore, we can simplify this equation into the next equations, and that equation is like this. Therefore, we can assume that therefore here I can write we assume that T1 equals to T1 square equals to T square plus alpha and T2 square equals to T square minus alpha. This is the difference in the time period. Suppose in the first case means when pendulum is suspended at the stage K1, then time period is calculated, and that time period, if there is some difference by adjustment of these weights, then that difference we suppose T1 square equals to T2 square plus alpha and T2 square equals to T square minus alpha. Now putting these values of T1 and T2 in equation number 5. Here in this equation number 5, you have to put these values of T1 square. What is here? Here it is T1. T1 is equal to T square plus alpha, T square plus alpha square, T square plus alpha square, T square here in this equation into L1 minus T2, the value of T2 is T square minus alpha square into L2 equals to 4 pi square upon z into the bracket L1 square minus L2 square. Now simplify this equation. For simplifying it, we have to do some mathematical calculations. Now just this equation, I write this equation like this: 4 pi square upon z equals to the left hand side, that is T square plus alpha square into L1 minus T square minus alpha square into L2 upon this L1 minus L2. This is L1 square minus L2 square. This again can be simplified in this way, that is 4 pi square upon g equal to multiplying by this L1 to this bracket. Therefore, it is t square L1 plus alpha square L1 minus t square L2 minus become plus t square alpha square into L2. Alpha square into L2. Now, here this can be written as L1 plus L2 in one bracket and L2 plus L1 minus L2 in the second bracket. A square minus b square equals to a plus b in first bracket and a minus b in the second bracket. Now, taking something common from the numerator and simplifying. Here, I write that step here. That is, here I can write this 4 pi square upon z equal to here L1 plus this is L2, means from this term and this term we can t square take the common. Okay, therefore I write here t square into the bracket L1 minus L2 plus into the second bracket. Here from here we can take alpha square as common. Therefore alpha square can be taken common and into the bracket L1 plus L2 upon this numerator. It is like this L1 plus L2 in first bracket and L1 minus L2 into the second bracket. Again simplify this. We can write 4 pi square upon z equal to t square into L1 minus L2 upon L1 plus L2 into the second bracket L1 minus L2 bracket close plus alpha square into the bracket L1 plus L2 upon this L1 plus L1 plus L2 into L1 minus L. The same quantity in numerator and denominator will get cancelled. Here this bracket and this bracket will get cancelled. Similarly, L1 plus L2 and L1 plus L2 will get cancelled. Therefore, 4 pi square upon g equals to t square upon L1 plus L2 plus alpha square upon L1 minus L2. This is the simplified form of the equation. Now, here this equation is not the last form. We have to calculate this equation furthermore, and we'll see that part in the next video.